Okay, we're back again and continuing on. Now we finished off with our client chat window that we just talked about. Now let's get into our network communications part for our client connecting to our server. Now as you saw before, I had the server running over here, which is the same as from the server videos. And thankfully the client is very much like the server, and we don't have to do a whole lot. The client's actually easier than the server. The server was the hardest part. But we do need to do something about the client that we didn't have to do the server, and that is make it multi-threaded in order to make it read in. So we'll have to also talk about multi-threaded programming. So we'll get into that also, in addition to what we've already talked about here on this other part. Okay, so we need to do the client networked header file here, so we need to do our library file. If I go here and click on the new file here and I choose file, again that was here, and then new file, and I'm going to choose C++ header C. Okay, I'm going to say next here, and then I'm going to turn on debug and release, and I'm going to say client network .h. I'm going to remove that included part because that's annoying. I want it just like that right there, and then I'm going to tell it where I want to save it. In this case I want to save it right in here. Now I've already saved it in here, so again of course I'm not going to create another one that I've already created. So to go ahead and do a network client client network.h, client network.h, capital C, capital N, etc. Click save, and then you're just going to say finish. Of course, I've already done it, so I'm not going to do that because I would wipe out my file that I'm going to be teaching with. So that won't work, obviously. Alright, so pound include stdlib here, and totally up to you what you want to do on that. But there we are. And I could take away the .c there part of that, so that way it doesn't just automatically come in. Alright, pound include open close greater than less than sign string in here, and that's going to give us our string value, and that's going to let us use strings, and then pound sign, and of course we end up with pound if not defined, if in def here, so that's what that means again, if not defined, client network underscore h for the .h, and then if it's defined, then if not defined, then we're going to define it, sorry, and that'd be client network underscore h. And of course it ends with a pound sign end if for the structure. Alright, so back over here. Pound if define apple define mock, whatever. And then we're just putting in here SDL underscore net. Now we do need SDL underscore net installed into the system, and this is true on any OS, Windows, Linux, Mac OS 10, etc. It needs to be installed ahead of time. Now we already did that in the previous videos for getting established and set up for Linux. So, and we did that also with the server. So you should already be set up. Else if here Linux, then we're just going to do include SDL underscore net.h open close brackets, and then also else pound include greater than less than signs SDL underscore net.h here, and then we're going to do a pound sign end if, which ends this block but does not end this block here. Okay, just be aware of that. Also, quick note, point out, and let me go ahead and slide this back over again. Slide that back over again. Alright, right click on here and go over here to my build options, go to my linker, and you'll see SDL underscore net there. That needs to be copied to release and gamepad also, so don't forget to do that, as it is very important. Okay, with that, good to go. Alright, so class here, space, client network is the name of our class. So it's going to be the data type when we create an object. It's going to be called client network here. Open curly brace here, public colon. And then we're going to have client network here for the name for our constructor. Remember, our constructor is where we assign values inside of it to our variables, or shall I say properties, of our class. So const space char star here, and then I'm going to say server IP, comma, and then uint 16 server port here, close parentheses, semicolon. So the guy coded it up SDL in C basically. So I'm doing a C style string. I'm doing it as a constant because this isn't going to change when it's passed as it's passed in. So it's not going to change throughout the life of the function. So it makes sense just to make that a constant for what's getting passed in, and that makes things run faster in the program because I've set the constant. It's going to access it in memory quicker, and the way it's laid out here. So you're better off doing that. I also can't have something change it by accident too. So for performance reasons and for basically protecting the functions or whatever, it just makes sense to do it this way. Okay. Then tilde client network, open close parentheses, semicolon, that's our destructor. So this is going to wipe out anything that was created in memory that's no longer needed, and I think we have some things if I'm not mistaken. TCP socket here, space socket, so it becomes name socket. Now you remember previously we were defining these as structs. This is going to take the place of a struct altogether, and this is a much better programming structure than a struct is from C. C++ allows us to have not only the names and stuff in here, but also the functions too. So this makes a whole lot of sense to do it as part of the class here, and that's what we want to do. IP address here, pound IP. So IP address space star IP. So we're doing a pointer with IP address here, semicolon. And then we have static here, SDLnet underscore socket set space socket set. I think I still use socket sets. I'd have to look again. I changed up the receive because it made it work properly on the client as opposed to on the server. So you definitely need the socket set for the server side. I cannot remember if I ended up removing everything that had to do with the socket set basically from the code. Well, it works as is, so I don't feel like changing it right now. Might be able to streamline it a bit more because I don't actually use the socket sets, I don't think, for the send and receive anymore. Yeah, I don't. Yeah, there's really no need for the socket set. But as it is right now, I have it set up in there, so I just don't want to change it. Yeah, okay. Well, it's set up for it already. I don't feel like changing it. If you want to, you can go back and you can take it out if you like and recode it to where it doesn't require the socket set. Because you could literally code the client without the socket set. You can. You do need it for the server, but you don't have to have it for the client. And that does make a difference. Maybe it'd make it a little bit faster in performance. We're not checking to see necessarily if the client has received something or not. We're just having it set into an infinite loop pretty much until it's been told done by the client application here, and then it can close it out accordingly as a check on it. And so by setting that flag more or less inside the class here, which we'll get into in just a second, and that's what that bool done is for, we can make it close out of the thread in the application side. Well, I'll get into that later. That's jumping the gun right now. Let's keep it simple here for now. All right, so that's a static here. Int num sockets ready semicolon. So here we are with our num sockets, for number of sockets that are ready. And again, this ties in completely into our socket set, but I've got rid of that code. I don't even know if I use num socket set anymore. I was, but that was for the receiving, and it didn't work out well for the client. Let me see here real quick. So, yeah, it's not required anymore, it looks like. I'll try removing it and see if we have a problem or not. Alright, so we're still working. Just make sure our network communications go through fine. It says yes. I mean, I can double check it, but I don't really need to because the server just responded back. So yeah, see, it even says it here too. And that's how I can know that it just went through fine. But right here, yep, working, etc., and received the exit command automatically when I closed out. So yeah, it works. So yeah, we don't have to do anything as far as that goes here. We can just wipe out this comment here, and I can say save. Awesome. Alrighty, so that's not really needed anymore. Done is, however, and std : string receive, open close parentheses, semicolon, void send std : string send str, close parentheses, semicolon. Alright. And then we'll do private here. And so this lets us send a command here. Now this cool part about this, what I have it set up is it automatically opens up the connection, connects to the server upon the initialization process of the of the client connection. And it also automatically disconnects and destroys all the parts that aren't needed anymore in memory for the client here. So it closes out the connection here for the Destructor. So essentially, the moment the application is closed, it automatically disconnects and destroys all the things that are eating up memory seamlessly. So it's pretty clean. It goes and works out nicely for handling this whole process here. And then in the private area, we have the read buffer because I don't want people directly accessing that, and the send buffer. I don't have a problem people passing that in to something or whatever, but into like the send function, for instance, or the receive function over here, which when it receives, it replies with a C++ string, which is nice. But as far as the actual read buffer and send buffer, I don't want people messing with it. I also don't want people messing with the instance variable here too for the class, so that way we don't have more than one instance of the same class here for connections. Okay, so this becomes insanely easy to use class, where you just like pass it in for establishing the connection, and then you simply just use send and receive functions. That's it. That's all you do in this whole thing. And if you need to, you can access the the port and the IP address here from the IP, and if you want to, you can get to your socket information if you need to. And you can also check to see if something is if it's done being processed here, as far as the if you're done using the whole network connection, it needs to be shut down. That done variable can be there. So that's cool. So it lets you exit out of your thread for receiving, for reading. So that's nice. And at any point in time, that can be set. So that's cool. But by default, done is going to be equal to false. We're going to have to do a few things over here in our CPP file. Int client network : instance semicolon here, and that's going to, of course, because this was static, we need to do that for instance. And then we have SDL _ socket set space client network : socket set semicolon. And we have to do that also because this is static too, here for the socket set. So for those two reasons, both of those are static variables, so they have to be declared at the top of our .cpp, otherwise it will not work correctly. Client network : client network, because for our constructor here, const ** server IP equals 192 in quotes here 192.168.11.129 close quotes comma uint 16 space server port equals 7770 close parentheses. Okay, why are we doing this? So basically it's defaulting to this IP address. Now this is the IP address I pulled up earlier here. You notice that that's what we are right here. Let's see here. This is with the ifconfig command, right? and this gives us the IP address. Now, I know in a real scenario you would have to have it where they hand enter it. We're going to get into how to do that later on. That's a far more complicated topic in C++, and I'm wanting to do this in baby steps with classes, and I don't want to get into something really complicated right off the bat here, where we start doing garbage collection through a counter-based system with basically a wrapper class for a template base variable to do a shared object between multiple classes as a member of each class. So all that's going to be translated into English later on. Right now, I'm not going to go over that approach. We're going to take the simpler road here, and we're just going to implement it this way, where we just pass it in to the function. And this works fine right now for establishing the IP address. And you could actually use this where you could pass in a different IP address. Now, this is only a suggested one if they don't put in one. So you can still pass in a totally different IP address and it'll handle it fine. But having the graphical set up, unless you code the actual connection directly into the chat client window, you would have more than one object or aspect of the game engine accessing the network part of the system is going to be a problem. So we do need to set it up as a shared object. And I'm not going to get into that now. That is way more complicated, and that's going to be another set of videos for how to do that as we go into that. And then we'll do UDP at that time too. So right now we're holding off. This is just TCP only right now, which is the main method, but UDP is popular for games because TCP checks everything to make sure everything's accurate, and UDP doesn't. It just sends it. So UDP is great if you're just doing like video or something like that, where you don't care if it's accurate or not, so much as you just need the speed to get it there. And UDP is faster because it doesn't do any checking; it just sends it. So because of that, UDP is going to be quicker. So be aware of that. Okay. So instance equals 0 semicolon, socket set equals null. IP equals new IP address semicolon, and done equals false. And I don't need to create, I don't need to do a, I'll just go ahead and delete this altogether. You don't need to declare socket set as new memory within the system, which is great. SDL net init, I did the initialization of SDL net inside of the actual network system, which is great. So I don't have to do that over here in the main. Whenever I call this window to have it created in main, it automatically will also do the SDL part of net for me too. So this really just hides that extra amount of effort for initialization, and all that is automatically done within the actual network class here for client side, and this makes it easy for us from our standpoint, because it makes it nice and tidy, because now I don't have to throw all that extra code into the top like it is here inside of I'm showing you a better way of basically doing this inside of the main function here. I've been avoiding doing this because it's gotten to a more complicated topic of classes, and I wanted to show how to break down and focus more on SDL. I kind of felt like you already saw a bunch of this stuff for the server side, so the client wouldn't be a sudden heart attack. So I felt like I could ease into classes this way, so I can show you class definitions and the way you develop classes and how to implement them, and also show you how to implement the client side without it being a sudden heart attack. Seeing just because a lot of the stuff is the same stuff you saw before, with only some slight variations here and there. So for making it work for the client. So, and it's also simpler, anyways, than the server that we did earlier. So for a lot of reasons, this makes a whole lot of sense for us to do it in an object-oriented programming method. Okay, so with that said, let's move on with this. So yeah, we're going to fprintf and let it know that, hey, SDLnet is initialized error here. So there we are, and it's exit failure here, and it's an open close curly brace here. So resolve the host, and we are connecting to it. Okay, so we need to resolve the host. Now this is a little different because we're doing this for a client. It's not the same as it is on the server. Pretty close, but not quite. So if SDLnet underscore resolve host here. Here's our IP address for us. It's going to get responded back. Here's the server IP of the server we're connecting to. So we have to already know what the server IP is, and this is different than what it is for the server side. If you go back and look at the options on that, you'll notice a difference between the two. So yes, we do need to pass in the server IP. We also need to pass in the server port that we're connecting to. Because we are not being the server, we're not waiting for someone to connect to us, we are making the connection to the server. So we have to contact the server and let it know. Once that happens, it sets up our IP with our port and IP address that we get from the system. And this, of course, needs to be less than 0 so that we don't have an error. If it's less than 0, then there's an error. -1, it's going to be a 0. It's going to be an error. All right. So here we are with the error, and here's the get failure for exit. All right. Close the curly brace here, and going on here. So if open parentheses not open parentheses socket equals SDL net underscore TCP underscore open, and then here the IP, close parentheses, close parentheses, close parentheses, then we have an error because we were not able to open up a TCP connection. So again, we are doing this on TCP instead of UDP. Now UDP and TCP look a whole lot alike, so there's very little variation for switching between the two, and we'll expand on this class and make it a little better and a little more powerful, letting people choose between UDP or TCP for its connection. And then we can just wrap that into this current class here and make that seamless and easy and beautiful and just super easy to use for as a class object goes. And then that just makes life easy on your end for when you start coding this and using this for now on, forevermore. When you use this, you can just simply just call back to this and use it for all kinds of programs and functions and continuously reuse this class. And it'll just be super easy to code it in. You won't even have to hardly think about it anymore, pretty much after you implement it. So that's really nice. Also, we have these error messages going out to the console, but there's no reason why you can't have a pop-up window appear, since now we learned how to do GUI windows with an actual error message. So we can also have it kick it out to a file and also have it kick it out to a window when there's problems. If you don't like the idea of having lots of pop-up windows though, which this would generate 3 different pop-up windows if something happened like this, that'd be really annoying. Then just having it go to the file is not a bad thing at all. So I don't know what my thought on that is, but yeah, that's something you can consider. You can handle your own setup here. Okay, so that gets us opening up a TCP connection. Now if we keep your sockets here, this is where they are getting defined for your socket set. Actually, I'm going to go ahead and look into real quickly, see if I can't just quickly remove the socket set from it and run and do the program without the socket set. Hold on one second. I'll come right back to that. Okay, I'm back, and sockets are gone. It did it in just a few minutes, actually. It didn't take any time. So I just removed the socket set from the .h file here, and just really reduced the code. And also I removed it from over here because I no longer need to do it as a static declaration up here. Removed it from the basically from the constructor, so no longer need to set it there. And I also removed it everywhere down below. All that code about the socket's gone, including also at the closing part, which you haven't seen yet either. So it's gone from there. So I just removed it from the entire client, and it all works perfectly great and fine. So that's it. It's gone. So after here for the open IP here, we've opened up the IP connection, and let's just move on here. All right. So std : string client network : receive open curly brace, and then std : string space message space equals space open close quotes, set of quotes here, semicolon. And this is what we're going to be passing in a message, right? Well, not passing a message, sorry. We'll be receiving and storing the message into message and replying with that message back. So this is really important when we want to have the message replied back from our class. Cool. All right. So if SDL net _ TCP _ receive open parentheses socket, comma, read buffer, comma, 512, close parentheses, space is greater than 0, parentheses, then we need to receive something here in this case. So printf here, server says blah blah blah. Well, %s is going to be, it's going to say whatever read buffer says, right? /n here in quotes, and then semicolon, and that's going to make it display to the console here. If you want for a session, you could have it do that right there for fprintf, so that way it gets stored to a file. And then we could just do, I don't know, standard out. I can't help myself. I always I keep recoding it as I go. It'll still work. I promise. I promise. Let me run it. Alright. So over here. It works. These are very minor changes, so it's really easy to just nail it the first time and not even sweat it. So anyways, there we go. I edited it and it works fine. So now it's fprintf and it kicks out to the file now. And it didn't crash or nothing, so it's great. Alright, and then message here from the read buffer, we're storing in the information that was read in from the server, and we're dumping it directly into the message. And then from message, it's going to go straight to returned back to our application. Now we do a few things here. We do want to exit our application upon receiving something from the SIM buffer. So if someone types into the SIM buffer at any point in time, exit here, we need to take appropriate actions for killing that connection, and we do. And so this sets our done here, lets us know that we need to exit out of our client read operation for our thread. So this automatically kills our thread for reading. So that does that. So it takes care of that, and it also is going to make it go into a kill function where it goes into the destructor of this class and automatically disconnects from the server and automatically shuts down, removes all the memory that's been eaten up for any operation for this send and receive part. So this takes care of that, and it doesn't matter if it's /exit or /quit. If it gets either one, someone's typed into, it's going to automatically do this, where it automatically goes into shutdown for this class object. So that's really great, and that keeps you from having problems for a number of reasons. And this lets you get out of your thread, no problems, no hassles. It's handled internally. So if someone types something somewhere else, I don't care. It doesn't even have to be typed. It can just come from anywhere in the application. Maybe you send that you're disconnecting to the server from a whole other part of the application that has nothing to do with the actual typing it in. For instance, right now we have it set up to where if you click on the X button here for, okay, let me show you something. We have it set up with the destructor that if you click up here, right, that makes it exit out. Well, that disconnected from the server, which sent this exit here, and then this receive is going to pick up that, hey, this exit is being sent out, right? And so when it detects that, it's going to set to done, and it's going to also exit out of the thread too. So this basically lets us communicate across multiple sets of processing parts within multiple things accessing this whole our whole network class here. And so this way we can use multiple things working with it, no problem, and be able to shut down the connections and let all the different parts know about it. Essentially is what the point of that is. And it makes life, makes it seamless, makes it clean, and makes things just happen and work properly without having crashes or issues or warnings or anything of that nature. So that's really important. That's really good. We don't want to have memory leaks, and we also don't want to have connections failing at any point in time for no apparent reason. So this helps keep things the way they should be, more or less. A return message, so whatever message that we receive, we're going to return it from this receive function, or shall we say method, because it's part of a class. A function that's part of a class is a method. I'll keep saying this stuff over and over until it's pounded in your head. Close curly brace. Alright? Good. that ends that method function, whatever you want to call it. Alright, so void here, client network : send open parentheses std : string space send str close parentheses. Okay, what does this mean? Well, we're going to send a string, a message, if you will, to the server. So that's what it is. We're taking in a string and we're just calling it send str for send string, basically. And hopefully that makes sense. I did this as a lowercase s because this is not part of the class. So there you go. Open curly brace here, str copy. So we're doing a string copy, and we're going to copy our send string.c _ str open close parentheses into send buffer. And the reason why is because this is a C style string. So I'm doing this string copy to make that work properly. And I'm typing a regular string, a C++ string, into a C string by doing the C _ str. And that allows me to do that and get away with that. So now I can do my string copy, and I'll do it with a semicolon here at the end. Alright, so it's going to copy the contents that was passed in as a string into my send buffer to be sent out to the server, and gets it into a C style string that's required. Alright, so int, and we can only have a maximum of 512 characters at once. Int space len equals strlen here, open parentheses send buffer close parentheses +1 here semicolon. So what are we saying? We're saying find the length of the buffer +1 because it's a little off on the length otherwise. Don't forget that you have that terminating character at the end of your string that determines the end of the string. So we have to account for that character. So the way to account for that character, and that character, by the way, is /0. It's at the end of the string, or is it? Wait, it might be /0 like that. Yeah, I think so. So I think it's that way /0. Anyways, it doesn't matter. It's hidden inside the string, and that's what's the terminating character to let C++ or C know that that's the end of the string. Essentially, is how you do that. That's kind of how it works. It checks for that character automatically. So that character is dependent to every string at the end to let it know when it's reached the end. And because of that, we need to account for that one character. So it's actually one longer than what it says it is, because it's getting the length of the string without that /0 character in there. So we need to account for that and add one back for it. Okay, so with that said, I'm going to say if here SDLnet _ TCP _ send open parentheses socket comma open parentheses void space stars close parentheses send buffer comma len space len here for the length close parentheses space less than space len here close parentheses. Okay, what does all that mean? Okay, so basically we're sending through with TCP. Again, this is a TCP connection send. We're sending across the socket that we have for communications, and we're sending our text here with our send buffer, and it's of the length that we determined over here. So this lets us know how long it is. And as long as the length is less than the length of this, when it's all said and done, we're going to go. Otherwise, we have an error. Okay. Close curly brace. We have nothing to return. We sent it. That's it. If there's a problem, there's an error. If you want, you could set up a return type here to where you give it like a false or true as to whether or not it was successful. So you could set that up if you so desired, you know, and then change it over here too. It's totally up to you. I don't really care, but you know, it's up to you, however you want to do it. Now we need to do our destructor. Okay, so first off, we need to send our exit before anything happens. So this is going to call back up to our wonderful function up here that we just finished defining and make use of it. And we're going to send the exit to disconnect from the server for our client when we need to destroy this object. Then we're going to close our socket afterwards. Now, of course, we have to disconnect from the server before we close our socket, because if we don't, we can't send the disconnect communique to the server, if you will. And then SDLnet here _quit to quit SDLnet aspect. And it's possible to still have the application going, and still possible to keep running as the whole program runs and not have it shut down SDL. Instead, I can have it shut down just a subsystem of SDL, and that's essentially what I've done here. So I'm shutting down the SDL net subsystem and not SDL net, and not SDL itself. So that's important to note here. You can shut down different parts of SDL as long as it's not the main SDL. Because once you shut down main SDL, you just shut down everything for SDL. But we're just shutting down a portion of SDL, and that's what we're doing here. And that's why I'm doing SDL net here underscore quit, open close parentheses, semicolon. That lets me shut down that portion of it. Delete IP, semicolon, lets me delete my memory allocated IP address here. So yeah, we did do a new, so we need to free that memory back to the system before we close out. So we need to delete the IP. That is important. Semicolon, close curly brace, and that's basically it. That covers our network class. And then next we'll need to go into actually how to set up the thread and implement it. And we'll do that in the next video. Because this is a rather involved process, I guess you'd say, for doing this whole thing with all the classes. But you can see how simple and easy the implementation becomes then on the main area and the main function. And then we can use this in umpteen other programs later on, for these classes. And you just easily pop this code in at any point in time, and this keeps your code really short and simple, and life becomes beautiful and easy when you code like this. And it just makes things so much better. As long as you make sure you don't have memory leaks in your classes and things of that nature, then you're okay. When you start having memory leaks in your classes, then it becomes a problem, because if you have a memory leak in a class and you use that class on a bunch of different applications or programs or different parts, then you'll just be, of course, multiplying that memory leak. So that is the downside to classes, but by far and large, the benefits, I think, far outweigh the negatives of it. And so do a lot of other people too, for that matter. So this is pretty standard in the whole programming industry, period, and games also. So you'll see this all over the place, really. But with that, that covers the networking class side of things. We did manage to get rid of the sockets. It is a little cleaner and smaller now. Well, socket sets. We still have sockets. You have to have sockets, but we don't have the socket sets anymore. So now it's a little cleaner and easier for the client. Things are even simpler than they were before, and switching over to UDP will be no big deal for client. It's a little bigger deal for the server, but for the client it's going to be super easy. So with that all said and done, my name is Nate Nestler, and this is for Hyperactive Studios. Thank you very much.